right, guys, today we're going to do lesson 4.12, and this is where we're going to take a look at whether triangles are similar or not using the AA postulate. We're also going to solve problems involving similar triangles. So, when you take a look at the warm-up, notice that you have two similar triangles here. We have lots of different angle measures and side measures, so just look carefully. Number one is find the measures of X and Y. So let's see. When you take a look here, you have X right there and Y right there. So this time we're dealing with angle measures. Okay, and notice that you have, there's two ways you can actually do this, okay? But if you notice, you have 80 and 48, so you would add those two together, 80 plus 48, and you get 128, and then take 180 minus 128, and when you do that, you get 52. So X is 52 degrees. Okay, and then when we go to solve Y, okay, and I don't know if you noticed already, but if this is 52, okay, notice that you have 52 and 48 already. So ring-a-ding, if you paid attention, you're going to know that Y is going to be equal to 80 degrees because as we've discussed numerous times, the three angles inside of a triangle add up to equal 180. And if two of them are already congruent, then you know the third one is congruent as well. All right, so number 2 tells me that the two triangles are similar and they want me to find W and Z. So let's see here. W is this side over here and Z looks like the base of this triangle here. So let's see. The first thing I need to do is I need to have a constant. And when I look at this, I'm seeing a 15 and 25. So that's definitely going to be my constant. So if I find, let's see, and I'll do W first. So I'm going to put 15 over 25. Let's see, I got to be sure I have plenty of room here. So 15 over 25 is equal to, I'm going to find W, so W over 20. Oops, it's a daisy. Oh yeah, that's correct, W over 20. And then I cross multiply and I get 25W equals, and then 15 times 20 is 300. Divide by 25, and W is 12. Now again, I have to use that same constant because now I'm going to find Z. So I'm going to use 15 over 25. And to find Z, I would do 18 over Z. And I will cross multiply. 15Z equals, and then 25 times 18 is 450. Divide by 15, and Z equals 30. Okay, now it tells me use the true proportion. 6 over 8 is equal to X over 28 is equal to 27 over Y to answer the following questions. Find X, find Y. So look, don't panic just because you see all this in a row. This is your constant. You'll set it equal to that to solve for X. Then you take that same constant, set it equal to that to solve for Y. So don't make it harder than it is. Take 6 over 8 equals X over 28, cross multiply, and you get 8X equals 168. divide both sides by 8, and x equals 21. Okay, use that same constant again, 6 over 8. This time you'll set it equal to this proportion, 27 over y. And again, you'll cross multiply to solve. 6y equals 216. Divide both sides by 6, and y equals 36. All right, good job. Now, let's move on to angles in similar triangles. Okay, the third angle theorem, which we've studied back at the very beginning of Unit 4, states that if two angles are congruent to two angles in another triangle, then the third angle is congruent too. And that's exactly what I just talked about in our warm-up. So the AA similarity postulate, if two angles in one triangle are congruent to two angles in another triangle, then the two triangles are similar. So it shows two different triangles here, and it shows that angle A is congruent to angle Y, and angle B is congruent to angle Z. Okay, so if you have two angles in a triangle that are congruent, then the triangles are similar. So don't confuse that with meaning congruent. Angle is not one of the shortcuts that we saw earlier in Unit 4. Don't confuse that with when we're making two triangles congruent to one another. This is simply saying that they are similar, okay? So don't confuse those. All right, so on example 1, it says determine if the following two triangles are similar. If so, write the similarity statement. So what you want to do is you want to take a look at this to determine, are they? So you want to look at that. You have 30 and 102, okay? We know that the three angles in a triangle are, you add them up to equal 180. So what you need to do is find this missing angle. So you would add 30 and 102 to get 132. Subtract that from 180 and you get 48. Okay, now when you take a look at the other triangle, note that you have 48 and 48 and 102 and 102. So because the three angles can only equal 180, that means obviously this other angle is also going to be 30. So my answer is yes, these triangles would be similar. They are not congruent. They are similar. And my similarity statement looks like this. This triangle is EFG. Triangle EFG is similar to triangle. Now you want to be sure you match up congruent angles. So which one goes with E? That would be L. Which one goes with F? 30. So that would be M. And then which one goes with G? That would be N. So L, M, N. Okay? Now let's take a look at the next question. Example 2. Determine if the two following triangles are similar. If so, write the similarity statement. So you just want to take a look here. You have 81 and 60. And just like we've done all unit long, add 81 plus 60. You get 141. Subtract that from 180 and you get 39. So 39 is the missing angle here. Now, you've already got a problem. You have 81, but you have 40, and neither one of these are 40, okay? And because you don't have any other option here, because the three angles will only equal 180. There's not going to magically be another number here. Okay, these two triangles are not going to be similar. So you would put no, and when you write no, you're not going to have a similarity statement because they're not similar. Okay, take a look at example 3. Are the following triangles similar? If so, write the similarity statement. Now, this one's going to kind of rock your world a little bit because I know you're looking at that thinking, I don't know. Heck if I know. Okay, so what you want to take a look at is these two arrows here. Hopefully you remember that means that those lines are parallel. So I know it helps for some of you that we turn it sideways. And when we have parallel lines, I've told you guys, anytime you see parallel lines, you need to automatically think to yourself, transversal, okay? And that's what's going on there. So you've got a transversal here. You also have a transversal cutting through here, okay? Oops, I kind of chopped into that E a little bit, but you also have a transversal here. So now you're taking a look at, could any of these angles be congruent because of a transversal, okay? Notice that here's your parallel lines. So we're talking angles that are outside of the parallel lines. I hope you remember that that's exterior angles, okay? And then when you look at it, you can see A and you can see D. They are on opposite sides of the transversal and they are exterior. So that's alternate exterior. Hopefully you remembered that that means they are congruent. So angle A and angle D would be congruent to each other. Another thing that you can look at is angle C and angle E, and I kind of chopped that a little bit, okay? But these two angles would also be congruent to each other. They are alternate exterior angles, okay? So now, so far, I have angles, exterior angles, that are going to be congruent to each other. And if you have two angles that are congruent, then you are going to have similar triangles. So the answer to that is going to be yes, they are similar. And now I need to write the similarity statement. So triangle ABC, oh no, excuse me, is that ABE? Yes, ABE is similar to triangle D, because I have A and D that are the same, don't forget that. So D and then B and C, because C and E were congruent to each other. So remember, doesn't matter what order the first one goes in, but it does matter the order that the second one goes in. All right, example 4. This is telling me that triangle LEG is similar to triangle MAR by the angle postulate. They want me to find GE, which is here, and MR, which is here. So what you need to pay close attention to, you guys, is that notice that you have this angle and this angle that are congruent, and then you have this angle and this angle. So really, this triangle could be turned just a little bit, and that would help you line it up exactly, okay? I need a constant. And if you can tell, if this triangle got turned just a little bit, 32 and 24 are corresponding sides in that triangle. So that's what I'm going to use as my constant, is the 32 and the 24. So 32 over 24. Now, which one do I want to find first? Well, let's see. GE is this side, so I guess I'll find that one. So 32 over 24, and GE over the side that corresponds to GE is 21. Cross multiply. 24 GE equals 672. Divide both sides by 24, and GE equals 28. All right, again, I'm going to use my constant of 32 over 24 equals, except this time I'm going to find MR. Now, MR is the bottom here, which means 20 and MR are corresponding. So 32 over 24, 20 over MR. Cross multiply 24 times 20 is going to be 480 equals 32 MR. Divide by 32. And MR equals, uh-oh, I think I just broke my lid. Nope. Oh, yes, I did. MR equals 15. Okay. All right. Now, the very last thing we're going to talk about is indirect measurement. Now, I hope you recognize this little picture here, because when you guys were in 8th grade, you did a bunch of that. And the reason I know is because I used to teach 8th grade. So I know you have done this kind of a question before, okay? And the reason it's called indirect measurement is because you can use proportions, okay? And you can set them up to where I'm not actually running out there to the top of this tree and trying to measure what this is, okay? The shadow that it's casting. I'm not going to actually do that with a tape measure, but I can measure it indirectly, okay? In other words, to find out like the measurement of something, okay? So I can set it up as a proportion like we've done in these other problems, and then that way I'm able to actually solve it without running up there and measuring a big long shadow, okay? So this is how you set it up. For example 5, it says a tree outside Ellie's building cast a 125-foot shadow. At the same time of day, Ellie cast a 5.5-foot shadow. If Ellie is 4 feet 10 inches tall, how tall is the tree? So we're going to take a look at that, and you're just going to match up corresponding sides, okay? You'll find a constant. You're going to set it up exactly the same way. So let's take a look here. Let's see, the shadow of the tree is 125 and Ellie's shadow is 5.5. So that can be my constant because the height of Ellie and the height of the tree, those are going to go together and the shadows are going to go together. So that way you're able to set up. So this is my constant, okay? Doesn't really necessarily matter which one goes on top. I'm going to go ahead and put 5.5 on top, which means Ellie, okay? And then 125 on the bottom. That's going to be my constant. Now, when I go to set this up, I'm going to match up 5.5, which is Ellie's shadow, and I'm going to put 4 feet 10 inches here. And these are both feet, I believe. Yes. Okay. So then what I'm looking for is how tall is that tree? And you can't get out there and, get a parachute. I don't know how you would do it otherwise. That's why you can do things indirectly. Okay. All right. So when you take a look at this, the first issue that you're going to have is that here you have feet and here you have feet and inches. Now, if this were 6 inches, I could very easily say 4.5 feet. But because I have 10 inches, I have a problem. I'm going to have to convert this. So this is kind of why we talked about converting measurements in our last lesson, because that's what you're going to have to do first. Otherwise, it's going to be really messed up. So I'm going to have to convert all of these to inches, and then I can properly compare them. So 5.5 feet is actually 1,500 inches. And then 125 feet, I'm sorry, that's backwards. Getting ahead of myself. 5.5 feet is 66 inches. There we go. And 125 feet is 1,500 inches. And some of you might be saying, how do you know? Well, all you have to do is multiply feet times 12 and your feet times 12 because there's 12 inches in a foot. Okay, so now I've got that set up. Now I just need to figure out about 4 feet 10 inches. How do I convert that? Well, 4 feet times 12 would be 48 inches, plus 10 inches is going to be 58 inches. Woo! And then X is what I'm looking for. All right, so now I can cross multiply. 58 times 1,500 is 87,000 equals 66X. Divide by 66. And X equals quite a large number, 18.18 inches. Okay, now if I wanted my answer to be in feet, okay, it doesn't necessarily specify in the question I have to put my answer in feet, okay, but I can, or this is the answer in inches, or if I take this, I can divide by 12, and I get 109.85 feet. So that's a pretty tall tree. So that would be my answer in feet. This would be my answer in inches. And that concludes our lesson.